welcome back to the channel. This is Onca Engineering and I'm Herman Wiegman, and today's video is about putting that back onto that. Shall we get into it? We do have to pull the pilot bearing out, and we need a puller for that. That's okay. We also have I'm going to cut away some more of this right through here so that we have a little more area to put the transmission in. I'll also cut it back here so that it's out of the way, and the same is true on this side here. We have to cut some of that away. Alright. Yeah, I still feel that bearing is no good. It has a notch in it. So that pilot bearing has to come out. But man, it's a bitch. I might have to take the flywheel off and pound it out from the backside, put a new one in on the bench. That might be the way to go. Hey, that's the nice thing about lightweight flywheels. They're lightweight. Alright, mystery solved. On this particular flywheel from ASCO Motorsports, the pilot bearing is inserted from the back side, not the transmission side. Alright, so the idea is then to punch it out that way. That might work better. Alright, I'm real pleased the way the pilot bearing insert went. It's a very smooth pilot bearing. We were able to tap it in from the back side, or the engine block side. So there was no way in hell the puller was going to pull that pilot bearing out because there's a lip on this side. Otherwise, this flywheel does have a metal friction plate that is applied with these Allen head screws and bolts. And so this can be replaced. It's to give the flywheel much more durability and reliability than if it were straight aluminum. So this steel plate does take a lot of the heat and a lot of the stress. Okay, this one only has about 12,000 miles on the previous clutch, so I'm thinking it's just broken in. It's feeling very good, so I'm just going to leave it there and run it with my new clutch disc. The important thing for me is not so much the ultimate torque holding capability, but rather focusing on the ability of this particular clutch with the double springs to absorb more torque ripple from the engine and not transmit it to the input shaft of the transmission. So that's the real experiment that's going on here. Alrighty, let's crack on. Before we set the clutch and friction disc on the flywheel, I just wanted to take an opportunity to look up here where we can see the crossover pipe that connects coolant between the two heads. And there's brackets here which run into it when you try to move the engine back. So now's a great opportunity for us maybe to play with these or remove these so that we can tilt the engine back to get the transmission on. And here on the top of the transmission is the 4-pin connector and the clutch pipe is out here too. And this is where one of the bleed valves is right here. Interesting. And this is a clip to put it onto the rest of the pipe. Well, that was easy. Turn the output shaft, put a pressure, and in it goes. These are just some long bolts I put here for placeholders so I could slide the transmission. We'll get the real bolts in now. That was a major frickin' success. This thing is really nice, this transmission jack with the wheels. You can rock it back and forth and get your input shaft right in. Okay, it's all about alignment, 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 and then orientation of the shaft. Okay, let's crack on. It's also nice having a printout of the directions showing me where all the transmission bolts go so I can get them all back in the right place. Okay, a quick tour of the clutch hydraulic system. This is the hydraulic fluid reservoir for the car, and right here on the side we can see the hose which goes to the master, which is back behind the bulkhead, probably on the interior of the car. The line comes out of the master over here behind this heat shield, and it goes right here to the top. So this is the highest point in the clutch hydraulic system. It then goes to metal line, which there is a valve where we can start to bleed the system right in there. And then it goes down to the slave cylinder, which we can just see behind that aluminum line. So the slave cylinder has a bleed point and the hose right behind the symposer there. Two places to bleed. Okay, I've attached a rubber hose to the middle bleeder point where there's also a twist valve, and I believe if I twist it open, that opens that valve into the clutch line, and then I can suck out, because I have a evacuation system here, which is nice. Some of you may have seen this before or at various popular tool stores, and it does have both an evacuate and a dispense, so I can pressurize and push fluid into the car, or in this situation I'll be evacuating and sucking the hydraulic fluid into this reservoir. Okay, I was just inside the car pressing on the clutch pedal about 10 times. This is the hose that goes to the intermediate bleed valve, not the one down in the slave, but the one that's halfway up to the clutch system that's attached to the car. So I have the hose attached to that mid bleed point, and there's actually an air bubble here or two. Those might have settled into the line, but we'll open up the valve and see what we get. I also had to make sure that we keep the reservoir topped up. Because there are some notches and some different segments of this reservoir, I'm not sure which segments for the front brakes, the rear brakes, or the clutch. So I've just been adding fluid here, keeping it topped up to ensure that all portions or all segments of that reservoir are being supplied sufficient brake fluid, because I don't want that to run dry, because then we'll just pull air through the system, and that just really sucks. Okay, let's jump back on, open the valve, see what happens. Let's keep an eye on these air bubbles. And open. There they go, and a few more air bubbles. Well, if we've got the evacuator out, and we've also serviced the brakes at the same time as the car was up on jacks, these rotors were turned so they're nice and clean. Nice new Porterfield RS4, I think it's R4S street pads are in here. So there's a single bleed joint per caliper. We'll just run around and pop it open. That ain't right. I got that in upside down. I got this flipped. I'm gonna flip it around. Fuck. Oops. I forgot something before I put the muffler up. Have to remember cross brace. These are the two bolts from the rear subframe, the two forward ones that hold the subframe and the cross brace to the back of the car. And when I took these out, water came out because the area behind the bolt was filled with water, probably from splashing in the rear subframe area from, driving in the rain or whatever. So I decided to cut a notch with my Dremel tool through the washer, not all the way through, but a portion of the way through. So hopefully that will become a weep hole for the water to get out so that it doesn't accumulate and cause all this rusting. Imagine if it gets up here to the threads, that would be really bad. Alright, let's see if that works. I have to test that over time, or I don't know. We just have to go with it. I just thought I would pause here for a minute just to comment on the rear cross brace, which covers quite a bit of ground, probably 2 square meters under the back of the car. And it's a fairly stiff piece of metal, and so it took quite a while to line up all the bolt holes and get everything aligned before cinching it up. So best not to torque anything down until you get everything in there. Alright, let's crack on. Alright, moment of truth. I have the car primarily back together. Transmission's in, exhaust is in, the drive shaft. Some items like the lateral bracing, they aren't in yet, and another shield or so. But this is the point where we have the car off the ground and we can give it a bit of a test run. Go through the gears, see if the clutch is working, whether we have to bleed the hydraulic circuit again. Let's find out. Clutch down. Car in neutral. It won't going to first. Let's get rid of the maintenance mode. Car will not go into gear. Yeah, alright, the clutch is not bled. We'll have to do that again. I thought I'd stop the video series at this point. I've been able to put the whole car back together. All the bits and bobs went back underneath, the cross braces, the under shields, etc. And so the question is, can the transmission be removed and reinstalled in your Jaguar F-Type manual particularly in a home mechanics around? And I think yes, with common home mechanic tools, it was possible to do this job. Was it a big job? Yeah, it was. I'd give it about a 7 out of 10. How's that for a Herman score? But the transmission removal was relatively easy because that was the only heavy part we had. And I also had the assistance of a nice transmission jack, a scissor jack. It's one of my new favorite tools because it also allowed me to lift the exhaust up or lift the rear muffler up. And so it's a handy thing to have around. But it's not big enough to handle the rear subframe member, which has all of the drivetrain and suspension components on it. So that's why that particular job we found was too difficult for a home mechanic with common tools. And I'll be going to a shop locally to have that done when needed. Alright, so I'm just going to give you some highs and lows, things that went well and things that didn't. I've already said the first high is having that scissor tranny jack. That's my new best friend in the garage. And a negative was the engine crossbar support. That was, I used it to hold up the backside of the engine, but it turned out I didn't really need that functionality. The engine was balanced on its engine mounts, and I actually had to use a floor jack underneath the engine to lift up the front side of it to angle the engine rearward or downward so the transmission could be installed. So the engine crossbar is not something you need. My little 14-inch floor jack, well, it's height challenged. I'd probably get a larger one, better one, because this car was lifted off the ground 16 inches. And I think that poor little floor jack probably only had a 14-inch throw. But if you want to take the transmission out from underneath your car, you will have to raise it more than 18 inches. So think about that and maybe have taller or more capable jack stands and floor jacks. I've already spoken about the engine angle being fairly critical for mounting the transmission. That was one of the key issues with reinstalling, is aligning that. And then, of course, the final step was spinning the output shaft of the transmission to engage the 23 spline input shaft and have it slide right into the clutch. And that was great. The last element that's sort of frustrating me is the bleeding, particularly of the clutch circuit. And I'm going to add a diagram on the screen so that you can see that there are a few high spots. And in this particular removal, I disconnected the clutch system right at the intermediate bleeder. I thought that would be convenient. I'm not sure there's a better place to disconnect. It was easily accessible, and there's a bleeder nipple right there, so I figured if air was introduced in the intermediate part of the system, it'd be relatively easy to bleed out, either through the intermediate nipple or forcing all the air down through the slave bleed point. But I'm getting more equipment, both a positive pressure system as well as my vacuum pump. My vacuum pump can also eject, but I'm getting a positive pressure bleeder tool. I do have two more things I'd like to show. Let's go over to the workbench. So I do have a few parts left over. I did remove this mass that is at the base of the shifter lever. It's to give the shifter throw a little bit more positive engagement. But I figure if we have a lightweight clutch, why not have a lightweight shifter? I can easily put this back in later. This is an O-ring or a plastic ring that goes at the base of the rubber boot, but I had difficulty getting the rubber boot to engage properly on the metal of the car, so I took this and kept the ring out. I have a few rivets left over from the rear brake guards. They were riveted on with aluminum rivets, and I replaced those with M10, or I should say 10 millimeter M6 hardware. The only other thing I have left over are some broken plastic clips from the wire harness on either side of the transmission. So overall, Pretty good score. No nuts, no bolts, no nothing left over. Everything went back as it should. Here are some additional tools that I think you should consider. Obviously, the clutch alignment tool, that's necessary. Otherwise, you'd really have a tough time. You could probably fashion one up, maybe using wood or 3D printer, but as long as you have something that can align the clutch up to the disc, that's necessary. The other thing I found helpful in reassembly was having these two bolts. As mentioned by Hermit the Crab and others, these are M10 1.5 thread, and they are very helpful. These came from a Volvo, and they enabled me to hold the transmission in perfect alignment while trying to stick the output shaft in. Here's another necessary item. This is called an E12. It's basically a Torx T50 socket format, but this is necessary for the drive shaft bolts at either end, the transmission side and the rear differential side. And of course, I also recommend you get a wobbled extension bits. They were really helpful in getting the 15mm nuts back onto the various locations on the catalytic converters to make those connections happen again. Really hard to get to otherwise. I did make myself a tool for holding up the back of the engine, but we don't need that. And finally, I had a simple block of steel that I found useful because it's just the right length, and I can flip it either one way or the other to lock the flywheel in place so that I could torque the bolts or untorque the bolts depending upon which way I needed them to go. All right, there you go. That's an overview of the special tools needed.
I hope you like this content. This is Anka Engineering, and I'm Herman Weigman. And remember, drive well, my friends.